Welcome. So this video is going to cover acid and hydrate naming. All right. So we've gone over the naming for two types of substances, okay, so far, ionic and covalent. And now we're adding sort of two specific categories of compounds, acids and hydrates. Okay. So as we go through them here, I'm going to explain sort of what each one is and then give a breakdown in general of how we know which one is which for all of them. All right. So, acids, come here. Okay. Naming acids. You first have to identify the formula as an acid. The way you do this is you look, and if it begins with hydrogen, okay, H plus, it won't have the plus, it'll be in a compound, so it'll have H. If it begins with hydrogen, it'll be an acid, except water, H2O. So if it starts with an H, for what we do, we're going to call it an acid. Then you ask yourself, is the anion, the negative part, monatomic or polyatomic? So acids are made with ions, the cation and anion. The cation is always H plus. The anion changes. If the anion is monatomic, the acid name begins with the prefix hydro. If it's polyatomic, the acid name has no prefix. Okay, no matter which one it is, A or B, then the next thing, you change the ending of the anion to "ic." Change it to the suffix "ic," and then you add acid at the end of the name. So let's look at a couple here. We've got H2S and H2SO4. Both start with H, so that we've identified them as an acid. Is the anion monatomic or polyatomic? So in the first one, everything after the H, there's just one element, just the S. In the second one, there's two elements, two capitals, S and O, so that's polyatomic. So this is monatomic, this is polyatomic. If it's monatomic, the acid name begins with the prefix hydro. So we start with hydro, then we change the ending of the anion to "ic." So anion is sulfur. So you start hydro, sulfur, and then you add "ic." Change the ending to "ic." Hydrosulfuric acid. Okay. All right, let's look at the polyatomic one. This is polyatomic here. So you don't put a prefix on it. It's sulfur, then you change the ending to "ic." So it's sulfuric. And then you add acid. So the only thing that's different between the two naming is this step right here. Okay, everything else is the same. Okay, the really important thing that you remember is that putting hydro on it has to do if the anion, the negative, is monatomic or polyatomic. People all the time get confused and they think because it starts with an H, the hydrogen, that we're putting hydro. That's not why the hydro's there. Okay, it's about the anion. All right, let's take a look and practice a couple. So first one here, it's an acid because it starts with H. Anion, monatomic or polyatomic? Well, more than one capital, so it's polyatomic. Okay, so we look up the polyatomic name. So that would be, you look that up here, PO4, it's phosphate. Okay. So that's actually from phosphorus. So you would change that to phosphoric, and then you add acid at the end. Okay, now, what if you put phosphic? That's fine. I'm not going to be that picky. Some of them you actually cut off the ending and you change it to ick. Some of them, like sulfur, you just add ick at the end. It just depends. You'll get a feel for it, what sounds correct and what sounds weird. You'll start to learn. But I'm not going to be that picky. I am going to be picky about the endings, obviously, because that's needs to be changed. It's supposed to be like that. But if you put like phosphic, if you change phosphate to phosphic, that's fine. I'm not going to mark that wrong. Okay. All right. Look at the second one here. HF. So again, it's an acid that starts with H. Anion is monatomic, just the F. So start with hydro. So it's hydro. This is fluorine. So fluorine turns to fluoric. So it's hydrofluoric acid. Okay. All right, next one. Okay, it's an acid, starts with an H. This part is monatomic. Okay, so it's hydro. Nitrogen turns to nitric, hydronitric, and then we add acid at the end. And let's look at the last one. Okay, H. Now don't freak out because it's got more stuff here. Still, the beginning, the cation is just the beginning H, so it's an acid. Then all of this is our anion, so it's a polyatomic. We looked that up. We find out that that is acetate, C2H3O2. So there's no hydro because it's polyatomic. So acetate becomes acetic, and then we add acid at the end. Just like that. Okay. Second sort of specific category is hydrates. A hydrate is any solid substance that has water molecules locked in its chemical structure. So this is one definition of a hydrate. Okay. Then there's a second definition here, which is the definition of anhydrous. Anhydrous means without water. It designates a substance that is not a hydrate. Okay, it does not have water locked in its chemical structure. Now I'm going to pause this for a second. Okay, so what I wanted to show you is a hydrate. Some people get the wrong impression when they see a solid substance that has water molecules locked in its chemical structure. They think that it's like in a solution or something. That's not it. This is copper 2 sulfate. Zoom out a little bit, maybe. This is copper 2 sulfate. Okay. This is actually a pentahydrate. If I zoom in, you can kind of see right here the .5 H2O. Okay, so it's copper 2 sulfate, and then you see it. Hold on, it's kind of hard on this label. Here, pentahydrate. It's over the 2 from here to here. Pentahydrate. Okay, but it's a solid substance. Okay, it doesn't but there's water molecules that are trapped, I guess you'd say, or locked in the chemical structure. There's water molecules locked in the structure as well. Okay, so that's one example of a hydrate. That's kind of how it looks. So, okay. So hydrates. You first obviously would have to identify the substance as a hydrate. Okay, the way that you do that when you're looking at the formula is all hydrates end in a dot, a number, and then H2O. So like if we looked at this, you see the formula, it's kind of fuzzy, but you get the idea. There we go. CuSO4.5H2O. This tells us that this is a hydrate. Okay. All right. You use regular naming rules on the first part of the substance, usually ionic. So the first part before the dot, you use regular, all the ones that we do are going to be ionic, so you use regular ionic naming rules. Then use a prefix that represents the coefficient number in front of the H2O. So the prefixes that we use from the covalent ones, like the monoditris, use those with these. Then after the prefix, add hydrate. So for example, okay, we've got Fe2O.4H2O. So in getting to this, what would we do? Well, we're looking at the first part here. Sorry, Fe2, I'll cover that up very well. There we go. Just look at the first part, Fe2O. Okay, we do that using the ionic naming. So you ask yourself, okay, do we have more than one? Does the cation have more than one charge? So you look at iron up, Fe. We don't know the charge, so that means it has more than one. So we've got to do the reverse. I'm just going to kind of do it over here. Reversing up the charges. Okay, we end up with Fe plus 1, because remember the first thing is always positive, second thing is always negative. O, negative 2. We check for reduction. I've got negative 2 on the oxygen here. We look on our periodic table. Oxygen is supposed to be a negative 2, so it was not reduced. So we write iron, Roman numeral, because we need to know the charge in the name. So Roman numeral 1. Oxygen, it's monatomic, so it turns to oxide. So iron 1 oxide. Okay, so this part right here, the stuff I did here, takes care of this first part. Okay. All right, now use the prefix that represents the coefficient number in front of the H2O. So let's see if I got more highlighters here. Coefficient number in front of the H2O. So the coefficient number in front of the H2O here is a 4. Okay, we use our prefix for 4, which is tetra. Okay, that comes from there. And then you just add hydrate after the prefix. The hydrate represents the water part. Okay, the H2O is represented by the hydrate. Okay, let's practice a few, see how we do. Okay, so the first part, the CAS, we're going to do ionic. So does the cation, the Ca, does that have more than one ion? So we look up calcium. Calcium is here, is a +2, so it only has one. So that means we don't need to worry about the reversing the charges and finding the charge, all that kind of stuff. We just start writing the name. So it's calcium. Okay. Our anion is monatomic, so we change the ending to IDE, so sulfur becomes sulfide, calcium sulfide. Okay, then we have that. Now the 6, we need the prefix for 6, which is hexa. And then we add hydrate. Okay. So calcium sulfide hexahydrate. All right, let's look at the next one. Al2CO33.2H2O. So again, doing the beginning part. Does our cation form more than one ion? Aluminum +3, so it does not. So we don't have to worry about reversing the chart, like reversing into the charges and finding all that out. It's just aluminum. CO3, we looked that up on our it's polyatomic. We looked that up here. Let's see, where's CO3? Here we go. CO3 -2 is carbonate, so it's aluminum carbonate. Okay, 2 is di, and then hydrate. Aluminum carbonate dihydrate. All right, third example. Cu2O.9H2O. So copper, you might know by now, does have more than one ion, so we'll need to figure out a Roman numeral for this. So for this one, we are going to reverse the charges. So I'm going to do Cu2O, and do that so I can, so we bring up, so we end up with Cu plus 1, O -2. We check for reduction. Oxygen is supposed to be a -2, according to our periodic table. That's what we have, so it was not reduced. So it's copper. Our Roman numeral is a 1. And our anion is oxygen, so it's monatomic, so we turn that to oxide. So copper 1 oxide. And then we need 9 is nona hydrate. So it's copper 1 oxide nona hydrate is the full name. Okay. All right, last one. FePO4. As you probably guessed, this one is going to have more than one. Fe. Don't know the charge, so we need to figure out the Roman numeral for it. So I'm going to do it down here so I don't take up all the room. So now remember, if it's a polyatomic and there's no parentheses, you don't bring up that number. You bring up a 1. So we're going to have Fe plus 1, PO4 -1. Okay, now we're going to check for reduction. We check the anion, the PO4. So if we look on here, PO4, according to our chart, is supposed to be a -3. That's not what we have. We have -1. So if the PO4 started out as a -3, what did we have to multiply by to undo this? Well, times 3. So we got to do the same thing here onto the Fe times 3, and we get a +3. Okay, so beginning part of the name, Fe is iron. Our Roman numeral is the original charge, which is 3. Anion is polyatomic, is phosphate. Got that from the polyatomic ion table here. PO4 is phosphate. Okay. Iron 3 phosphate. 5 is penta. And then hydrate. So the full name of this is iron 3 phosphate pentahydrate. Okay. That is it for the acid and hydrate naming notes.